Hello everyone, welcome to Exemplar Physics. In the last video, I have asked you a question. The question was, which electric equipment is used as a protective device that works on Joule's law of heating? Congratulations, most of you have answered it right. The answer is fuse. So fuse is an electric device that works on Joule's law of heating that acts as a protective device. Today in this video we are going to focus on the working of fuse. This would be a further discussion on heating effects of electric current, rather focusing more on Joule's law of heating, as fuse works on Joule's law of heating. And after the discussion, we are going to solve the question as usual. So I have also written the question which you can see. So let's start our discussion. You must have encountered a fuse in your home. So some of the fuses look something like this. It looks like a capsule or a cylinder, small cylinder with metal coverings at the end. So these are the metals, made up of metal. And if you focus in between, you see a thin wire passing through it. So this is nothing but a fuse. This fuse you must have seen in certain equipments or extension box or in your switchboard. There is another type of fuse which you must have seen near the entrance of your main electric supply. The fuse looks something like this. It is made up of porcelain and will have a metal bulging out. So this cuboid which I have shown here is made up of porcelain and it will have a metal bulging out like some teeth. And there would also be a conductor connecting both the teeth. And this fits into a socket which is made exclusively for it. So this is also the fuse. Where can you find it? Near the entrance of your main supply. The material used here it is porcelain and this is metal. So let's discuss how does the fuse work, and before that some basic things like what is a fuse made up of. Fuse is generally made up of alloys. These type of fuse are generally made up of alloys depending upon their rating, and these type of fuse consist of a single metal wire. Depending upon the rating, that metal wire could be copper or aluminium. So the alloys or these metal wires are which we use in them are according to the rating of the fuse. The rating of most household fuse are 1 ampere, 2 ampere, 3 ampere, 5 ampere, 10 ampere, etc. So these are the common household ratings. If you see in industrial circuits, you would find 15 amperes, 20 amperes. You can also find 25 amperes, 32 amperes, 64 amperes, 100 amperes and so on. So we are focusing only on the household fuse rating. Household fuse rating. So what does this ampere, why this rating is in amperes, and what does this number mean, we will discuss later. So these are the ratings, and so this material is made specially for these ratings. Now let us know where is this fuse connected and how is this fuse connected. Fuse is connected generally at the starting of the circuit, and it is connected in series with the equipment. This is connected in series with the equipment. Let me show it with some example. So we have, let's take one circuit here. The simple circuit which we are going to take will have only one equipment for simplicity. So let's take one 220 volt source. 220 volt source here, and switch. After the switch, here comes the fuse. So fuse is just kept before the equipment. So the equipment I am representing by its resistance. So this is our equipment. I am representing it with the resistance. Let me draw it with some other color. Our fuse. So let me draw it with blue, and let us complete the circuit so that current could flow. So I have just taken a simple circuit, a simple equipment represented by its resistance. So this is our fuse, this is our switch. When I close the switch, the current will start flowing through the circuit. So I have taken here 220 volt source, AC source, 220 volt, and as soon as I close the switch, the current will start flowing through the circuit. A very basic circuit I have taken. Suppose this is a water heater, and the maximum current that could flow through water heater is say 10 ampere. If more than 10 ampere flows through the circuit, then the water heater would get overheated and it would get damaged. So I am going to use a 10 ampere fuse. Now what does this my 10 ampere fuse will do? As the current flows through the circuit, say I, this current flows through the fuse and the electric heater. So this 10 ampere fuse will allow the current to pass through it, right? It will allow the current to pass through it up to 10 amperes. As soon as the current becomes more than 10 amperes, because of Joule's law of heating, or you can say heating effect of electric current, heat is produced inside the fuse. And because of the heating, the fuse would get melted. As soon as the fuse gets melted, the circuit becomes open, and our equipment is saved from overcurrent, that is current greater than 10 ampere. So what does the fuse do? It allows the current up to the maximum limit or the rating which is written in the fuse. If the current greater than this rating value passes through the fuse, then the fuse gets melted and it opens the circuit, breaks the circuit, and no current passes through the equipment, and my equipment is saved from overcurrent. I hope you have understood the working of electric fuse. Now we have a question here. Let me read the question for you. The question is, an electric iron consumes 1 kilowatt electric power when operated at 220 volts. What is the appropriate rating of the fuse to be used? So let us see and draw the circuit for this particular case. So here we have a electric iron, so we are representing electric iron with R by its resistance, and we need to put a fuse here. So what would be the rating of the fuse? We have to find that. So what would be the rating of this fuse? That is our question. So when a 220 volt is applied across the electric heater, it consumes 1 kilowatt power. It consumes 1 kilowatt power. So P is equal to 1 kilowatt. Voltage across it is equal to 220 volt. So current passing through the circuit is equal to, so we know the from formula of the power, P is equal to V into I. So I is equal to P by V. So let's put the values of power. 1 kilowatt. 1 kilowatt is 1000 watts divided by 220 volts. 220 volts. 0, 0 gets cancelled. 2 11s are 2 50s are. So this is equal to 11 4s are 44, 60, 11 5s are 55, 504 amperes. So what is the permissible, what is the current that would flow through the circuit? 4.54 amperes. So what is the most appropriate rating of the conductor fuse? Most appropriate rating of fuse that you could use is just higher than this value, and that is 5 ampere. So which rating of the fuse we are going to use? 5 ampere, just about this value. See, what are the fuses we have? We have 1 ampere present in the market, 2 amperes, 3 amperes, 4 ampere fuse is not there. Next level we have a 5 ampere fuse. See, if you use 3 ampere fuse, then what would happen? The appropriate current will not flow through the circuit before flowing of this 4 amperes. See there, 4 amperes. What will happen? The fuse will blow out. The fuse will blow out. Blow out means the fuse gets melted. The fuse would get blow out and the equipment will not work appropriately. So what we'll do, the rating which we have got, the current which we have got, we'll just take the higher value, and here in this case it is 5 ampere. So I hope you have understood. I have a question for you. You have to answer the question in the comment section. The question is, what is the material used in the filament of a bulb and what is its melting point? So please write your answer in the comment section. If you like this video, please click the like button and share with your friends. Thank you.